It's 2 a.m. You are physically exhausted, but right now, inside your skull, your brain is running a marathon. You might be replaying an awkward conversation from 3 years ago, or mapping out catastrophic ways your career could fail next month. When you tell yourself to just stop and go to sleep, the thoughts often seem to gain momentum rather than fading away. This experience is a reflection of specific neurological activity. It is the result of a predictable sequence of biological events that occur regardless of your intentions or your character. What you are feeling is a mechanical misfire, neural circuitry trapped in an open loop that lacks its usual regulatory control. To reclaim your rest, we have to look inside the brain and identify the specific networks involved in this cycle, and then apply the physiological interventions needed to transition out of it. In 2001, neuroscientist Marcus Reichel used fMRI scans to see what happens when the brain is supposedly at rest, finding it doesn't actually power down. This activity is concentrated in a specific network known as the default mode network, or the DMN. It acts as the brain's idle engine, shifting your focus inward the moment you aren't engaged with the outside world. The DMN enables mental time travel, allowing us to analyze the past and simulate the future, an essential evolutionary adaptation for avoiding repeat mistakes. For an overthinker, this system becomes hyperactive. The regulatory systems that usually cap these simulations fail, turning a predictive tool into a cycle of infinite what-if scenarios. This is the difference between problem-solving and rumination. Problem-solving is a finite process that ends with a plan. Rumination is a passive loop that revisits the same emotional distress without reaching a conclusion. We stay in these loops because the brain experiences a small release of dopamine during rumination. It is a deceptive signal that makes the subconscious believe this passive worrying is a form of productive preparation. If we can see that this worrying is unproductive, why can't we simply use logic to talk ourselves out of it? This failure happens because of a conflict between the prefrontal cortex, the brain's logical center, and the amygdala. While logic knows a thought is just a thought, the amygdala cannot distinguish between a physical threat and an imagined emotional threat. Once the amygdala detects this perceived threat, it triggers a stress response, flooding your system with cortisol and adrenaline. During this severe response, the brain physically routes blood flow away from the logical prefrontal cortex and toward the survival centers. This is why logic fails. You are attempting to reason with a part of the brain that has been effectively sidelined by your own survival biology. Since logic is currently inaccessible, you must use physical and sensory interventions to shift your brain's state. The first method is the task-positive network override. The brain has a network that functions as the direct antagonist to the DMN, called the task-positive network, or TPN. They function like a seesaw. When the TPN is highly active, the DMN is suppressed. By engaging in a task that requires complex sensory processing, like the 5-4-3-2-1 grounding method, you force the TPN to engage, which begins to draw power away from the rumination centers. The second method is the amygdala brake. Overthinking often leads to shallow breathing, which causes carbon dioxide to build up in the blood, signaling the amygdala to remain in a state of high alert. To counter this, use the physiological sigh. A double inhale pops open collapsed air sacs in the lungs, and a long, slow exhale stimulates the vagus nerve, signaling the heart rate to slow down. These physical actions help lower cortisol levels and create the physiological conditions necessary for the prefrontal cortex to regain control. The final step is cognitive offloading. This addresses your working memory, which can only hold a few items at once. The brain often loops the same thoughts because it is attempting to keep potentially important information from being forgotten. You can end this cycle by writing these thoughts down. Use a pen and paper rather than a phone, as the tactile motion of writing engages different motor circuitry in the brain. When the visual cortex confirms that the information is physically recorded, it can signal to the amygdala that the internal loop is no longer required to preserve that data. Understanding these mechanisms helps reframe overthinking. It isn't a permanent part of your identity. It is the output of an overprotective survival system. You don't have to be a passive observer of your own thoughts. By understanding these biological triggers, you have a repertoire of techniques to intervene in the process and find focus.